Hi everyone, my name is Annie. I'm here with my engineer Ben. We are from an energy company called Utility Warehouse. We're actually a direct competitor of Octopus Energy. So I was like, I hope it's still not the other Octopus. So yeah, we have a two-part bit today. So Ben will kickstart on the technical journey, so the more engineering type, and then I will follow by the business bit. And we have some time at the end for questions. So Ben will start.
Yeah, so as Annie said, we are Utility Warehouse. We are a multi-service utility provider in the UK, and we have over 1 million customers across the UK, and we get around about 100,000 calls from customers every month, which is quite hard to handle. So what we've done to kind of help us with that is basically build a web and WhatsApp chatbot for customers. We did have a video here, but we can't actually play this video, so here's a quick screenshot of what this looks like. This is one of our websites. The screenshot is asking what the difference is between a fixed and a variable tariff. And then you've got our bot answering it here. And then at the bottom, you've got some related links from documents that we use internally. And we built this to basically help our customers out of hours when we're not around. So the contact center will close at 6 p.m., 5:30 p.m. And if customers have issues, they can't get the help they need. So we built these kind of tools to help the customers get the help they need when we're closed. We use help articles from our website. We use internal documentation. And one thing we've gotten from this is a double-digit contact deflection, so we can answer questions and we can answer them well. What this does is it helps us smooth out the contact peak the next day as well, so when we come online at 8:30 a.m., we don't have 1,000 calls waiting because customers are getting the help they need out of hours. And one thing that we love about this is customer satisfaction has stayed the same. So some customers may be unhappy with speaking to a bot out of hours, but our bot is somehow giving the answers it needs to give, and customers are pretty happy. And then you've got some example questions at the bottom, like when will I get my first bill, what's an early termination fee, etc. And the bot can handle all these things. But getting to a bot like this is a long journey, and it takes quite a while to get to this point. So we've got kind of a walkthrough of how we got there and what our technical journey looked like. So what we started with doing is basically by creating a Hello World app. Now, your kind of simplest LLM app will be using a kind of a UI. You call an LLM, and then you return that to the UI. That's the simplest way of doing it. We kind of wanted to go a bit further and do something called RAG. I'm sure you all know what RAG is, but it's retrieval augmented generation, where you basically pull in documents that are relevant to the question and then add those to the prompt to answer your question. So we built a Hello World app using kind of our internal documents from something called Contentful. And what you can see on the left-hand side here is that we take documents from Contentful, we put them into something called an embedding model, where we turn the document content into a vector, and then we store this in a vector database. This vector database is in memory. So this is inside of like a Jupyter notebook when we're building this. What we did is then we showed this to a stakeholder and let them ask questions that we knew were kind of in these documents. So questions like UW, or when does my bill come out of my account, what's a partner? And then the LLM will take documents that are relevant to those questions, send it to the actual LLM itself, it'll respond, and then your stakeholder's like, oh my God, how can it do that? How does it know about my business? This generates a lot of buzz around the company, and all of a sudden, everyone wants to have these LLM-based apps in production. But getting this into production and getting it in front of customers is a whole different story to actually doing it in a Jupyter notebook in a one-on-one session. And this is kind of what we're here to talk about in a way. So going from hello world to the real world and getting stuff into production, there's a lot of things you kind of need to take into account. So stuff like, what LLM do you want to use? Are you going to go with OpenAI, go with Gemini, Llama, Anthropic, or DeepSeek? What embedding model are you going to use? So an embedding model is what you use to turn your documents into vectors and then your questions into vectors. There's many on there you can choose from. You need to kind of take into account how big your infra is and what you can handle. Then you also need to take into account what RAG hosting and infrastructure software you're going to use for this. So are you going to host everything internally on Kubernetes, or are you going to use kind of GCP's Cloud Run to host your API for people to call? And then there's two more things at the bottom. So one is a vector store. So when you're taking these documents and you're storing them somewhere, you need to store them in a very specific database that can handle vectors and kind of content. These are vector stores. There's things like Elasticsearch, Quadrant, Milvus, etc. And then finally, you've got your LLM frameworks, so LangChain, Haystack, and Llama Index. And this is how you kind of build your pipelines that can take yourself from starting from no code to having an actual pipeline. And this is kind of our tips for choosing this tech stack. So what worked for us? So the most important one is just start with what you know. If you have all your kind of infra in your business on GCP, don't kind of go for AWS. If you have everything on AWS, start with AWS Bedrock. Number two is select things that work together. So choose tools that connect easily for a stable and easy to build system. So if you want to use Elasticsearch as your vector store, and then you go with Llama Index, let's say, but Llama Index can't connect to Elasticsearch very easily, then you're kind of up a creek with that paddle. you need to build this kind of connector yourself. So choose things that work together, make sure everything works together nicely. Then we have keep it simple, so select something that scales well and is simple to maintain, and don't build what you don't need. You can Google RAG kind of system architecture, and that can come up very quickly. Anthropic has great articles on this, and you can kind of use what they say and build it. Don't kind of create your own superstructure, and don't build what you don't need. So if you don't need chat history in your app, let's say you built a system that a user says one message, gets a response, and you're done. You don't need chat history for that, so don't build it. And then finally, know your data. So if you know your data, you can make informed system design decisions, which are really important to kind of your documentation, your documents. So knowing things like how long are your documents. If they're very, very long, then you need to spend a bit more time working on your chunking and making sure your embedding models can actually, ingest these documents. How often your documents change as well. So if your documents are updating every single day, you need to keep that in mind when you're building your indexing pipeline to know that these documents are updated when they update in your kind of internal database. And then finally, are they PDFs? So PDFs can be pretty notorious to actually parse, especially if you're kind of using big tables and multi kind of columnar structures. They can be a right pain. So know what your data looks like and how to actually get through to it. This is what we ended up going with based on these rules and these pointers. So what we have is a customer will send a request. This is their prompt and a conversation ID. This gets sent through to GCP's Cloud Run, where our kind of API is hosted. This Cloud Run is connected to Redis, which is our memory store, which is a chat history. And this is also hosted in GCP because we want everything to work together. We use Redis because it's low latency and it's easy to access. We then store all of our vectors in Elasticsearch. So you send a prompt, it gets turned into a vector. We then find similar documents in Elasticsearch and send that back to the API. And then everything together gets sent through to OpenAI, where we'll then have it parse all of our documents, give a good response, and then send it back to the user. To build our framework, we used Haystack. We liked Haystack because it builds pipelines and it's easy to understand and kind of prototype with. And then for our indexing, so this is how we update our documents that we're using. We have a cron job hosted internally on Kubernetes, and this runs every day at 2 a.m. It queries a lot of different data sources. So, contentful, we've got multiple contentful different areas. We have internal documents like PDFs that we want to use, and all that gets done every day. So some pointers, more pointers. What we think is we should use configs for your parameters. If you're writing a large kind of RAG system, this will be multiple Python files of code for your memory store, for your document store, for your actual pipeline itself. This can get really big and really hard to kind of track where everything is. But if you have a kind of a config with all of your prompt templating and versioning, your indexing knowledge base location, update frequencies, etc., what LLM you're using, it's a lot easier to know what is going into this rather than having it hard coded in your Python files and you're kind of scrolling through 1,000 lines of code trying to find a needle in a haystack. One other thing that we want to point out here is make sure you use the same embedding model for indexing and inference. This is a mistake we made very early on, where we had an L6 model for indexing and an L12 model for inference, and then we were trying to see what our documents returned looked like, and they were completely kind of usable. We'd ask a question, and the documents returned were not relevant at all because we were basically turning the question into a vector, turning our documents into a vector, but those vectors had nothing to do with each other. So keep that in mind. Then some more things I think I mentioned earlier about chunking. So basically have a good chunking strategy when you're doing these type of things. So one thing we use is something we call context-aware chunking, which is basically when we let an LLM decide how to chunk a document. Chunking a document is basically when it's too large to fit into an embedding model. These embedding models usually will have like 512 tokens as a limit. So if you have a really long document, it won't fit into the embedding model, and then the vector it generates will not be relevant to what's in the content. So you need to split it up into smaller, more manageable bite-sized pieces. You can do this in many ways. So you can split it new lines. Every new line's a new document. After a certain number of tokens, every header you can split into kind of a new document. We don't think these things kind of like maintain context very well, kind of by themselves. So we use context-aware chunking, where basically if our documents are larger than 512 tokens, we'll send it through to an LLM like ChatGPT and tell it to chunk these documents up into smaller bite-sized pieces, which we then can embed. Next thing we've got is basically create a component to get sources for your responses. This is one thing we think is amazing for kind of transparency and visibility. So when you ask our chatbot any questions, it will always give you some related links of how it came up with those answers. Now, when you're doing this type of thing, you don't just want to kind of return one document from your document store. You want to pull out a list of things that the model can use. So we have a whole kind of aggregation layer that will basically look at these 15 documents we send through to our LLM, find the ones that were relevant, then get the links for those guys and append them to the end. So you can see here, we've asked, how do I explain what a cashback card is? And then we've got some links to what do I do if I need to cancel my cashback card? What is a cashback card? Why is my bill different, etc. And then a bit of a kind of a nudge on prompting. So one thing we think is really important is creating a well-structured prompt when you're dealing with these LLM systems and RAG. So you want to basically define the LLM's task very accurately and exactly. So we think you need to define the purpose. So mention what your LLM's persona is, what its task is, what its kind of boundaries are, what it can and can't answer. The classic, you are a helpful assistant, do not give any answers if the question implies debt. We don't want to give people financial advice, so we kind of cut that out immediately. Then you also want to tell your bot how to handle vague questions. If a customer is asking something that could be interpreted in many ways, then we want to tell it, follow up with the customer, ask what they want more specifically. And then finally, we've got stuff like how to handle knowledge gaps. This is basically if you don't have this documentation internally, what do you do? Do you try and answer it using what the LLMs know themselves, or do you tell it to, fall back to something like, I can't help you right now, please try again later, or contact our customer center? And then finally, one thing we like doing is having integration-specific guidelines. So you write these prompts in something called Ginger a lot of the time, and Ginger allows for some very nice templating. And you can basically add little things like the format of the output you want to do, and then you can have your template change depending on the format, which is amazing. And then finally from me, don't let RAG, if you build one of these RAG systems, be a backdoor, and make sure you keep an eye on your logs. So if you're building a RAG system, it should not give users access to documents they shouldn't have access to. So let's say you give your service account access to all documents in a database, it pulls out all these documents, and then it shares them with the user. These documents may have been only for internal usage, you just had too much permissions on your service account, and then users are seeing things that they shouldn't. Then number 2 is lock your doors, so make sure you protect your API endpoints, review your auth flow, secure your vector store, use a secret manager for any kind of secrets that you have. You don't want to have these encoded in like env files, because if something leaks or you accidentally go public on your repo, then everything's kind of there for people to steal. And then finally, watch your logs. So this is something that happened to us recently, where we had someone kind of sending in lots of gibberish and kind of trying to jailbreak our LLM. And if we were just kind of coasting around saying, oh, look, we've got so many requests today, that's amazing, we would never have noticed this. But we keep an eye on our logs to make sure that we can see when these nefarious things are coming through. And if they do come through, we will kind of IP block and then take some kind of time to build guardrails to stop this from happening. And that's it from me, at least. Over to you, Annie.
Yeah, I think we got DDoSed here, and that happened like 2 Sundays ago. There's a few ways to address it. You can kind of rate limit on the front end, on the server side, like there's different pros and cons for each approach. But the lesson we learned is that if you have a public-facing app, you are gonna get DDoSed. It's a matter of time. So what do you do with it? Do you do it yourself and stuff? So yeah, I'm here to talk a little bit more about the business side. A few advice. Like I mentioned, we are in the energy industry. We actually are regulated by 3 different regulators. We have one for energy, one for broadband and mobile, and then we have one for financial services because we have insurance product. So because we're heavily regulated industries, this means that when we deploy our GenAI apps, we have to rely very conservatively. So what that means is that when you set up a lot of default flows, if it mentions stat, vulnerability, elderly people, default to a human. We also need to make it very explicit to the customers that you are talking to a bot. So here is the WhatsApp flow, which says, hey, I am a virtual assistant. Ask me any question. You should also specify to the user whether they can talk to a human if they want to. Because sometimes, I'm sure you have all used it, some airline chatbot, you're forever talking to a bot, and all you really want to do is to talk to a human. So you should specify that if there's a way for them to talk to a human, or not, because maybe that's when they give up on this and they start calling you instead. You just don't know. So being clear with your intent is important. Security is very important. Like if you want to actually put something into prod, you need to engage your security team early, because like I said, our endpoint was only live for maybe a month before that DDoS started, so it's going to happen. Another thing that I want to learn is that you don't really know what's going to work when you start. So we actually have 4 bots. When we started, the first bot we did was for our call center agent. It took us 3 engineers a quarter to build that. And then the second bot, it took us 1 month, 1 engineer. Third bot, you can read. The general takeaway is that you don't really know what's going to work. So it's important that whatever you build, the infra, the code and stuff, they can be easily pivoted for a different use case or a different persona if the first one you build does not work out. We've also learned that once you build the first one, which took us 3 months, 3 engineers, it's exponentially easier to build everything after, because what we did afterwards is we just point to a different knowledge base. So the first one was just content for articles, and second one was like our internal help articles, which is not public and hosted in content for. You just need to change those connectors. Everything else from the web UI to the API endpoint can stay exactly the same. So you can deploy a lot quickly if you set up the infra that way. How to scale cheaply, that's very important, because when you go ask for budget to build this, they will always ask you how much. So a few pointers: if possible, batch instead of real time. So if you don't need a real-time API, if you can do like a cron job, such as document parsing, creating document summarization, it's 50% off if you can batch. And that's kind of everywhere. All the vendors have a much cheaper batch instead of real time. Similarly, if the question can be cached, so if you have a commonly asked question, caching them, if you can see, here's an example, input versus cache input, it's often more than 50% off. So if you have a common question that a lot of people ask, try to cache them. Make a trade-off between accuracy and latency. Now, there's a lot of models on the market. Everyone knows about the OpenAI old models. They are the reasoning models. They are very good in the reasoning, but a lot of people don't need it, because if you're just doing like text summarization, you don't actually need that good. You can pick a small model, and it's also much faster when you use those models. The old models tend to be quite slow, so there's higher latency, so you kind of have to make that trade-off if it's a customer-facing role. So choose an LLM that's good enough for your role. I will try all of them. I do not have a vendor preference. I think OpenAI is great. I think AWS is great. I think Gemini is great. I do not care. I think they are all great. Test and pick one that's good enough. So just want to give you a cost breakdown, because I think it's a commonly asked question. How much would it cost to run an app? So this is the example of the apps that you saw earlier on. I think this is just the WhatsApp version. So specs, 30,000 queries per month, latency 5 seconds. We are not going for fastest possible, because sometimes you want to make it localize their thinking. If it's too fast, people think it's not real. So you want to give it some buffer time. I know. So for that kind of spec, you can see there's some LLM costs. You can pick anyone, and it costs £300. Some VectorDB, some serverless app like Lambda to actually run that app. And then you have an indexing pipeline because you want to update your knowledge. And then you have some memory. Maybe you have some Cloudflare for your rate limiting. It's a little bit slack. But as you can see, for 30,000 queries, it's what, £500? It's pretty cheap. And that's what we learned, because running GenAI app is pretty cheap. What's more expensive is always going to be your engineer time, because an average engineer 1 month is going to be 5K to 10K. So it's more your team's time that you need to justify, rather than worry about how much your LLM service is going to cost. Hallucination is a feature, not a bug. I'm sure you've heard of some cases. How to address them. There's some quite common things, but I think the most important is to define an acceptable error rate with your business stakeholder. So the example I've shown you is a customer-facing one, but if it's an internal-facing one, maybe your error rate could be higher. If it's a legal case such as Octopus Legacy, obviously it will be lower. So depending on your use case, what is the margin, or what's the magnitude of error that your business is willing to accept for the amount of savings that they are willing to they are looking to get from the service. Set up your params, such as top K or temperature conservatively. Set up some guardrails, have some test data. Use another LLM to check hallucinations. So you have your LLM that's creating the answer. Maybe use another one to make sure that it's not hallucinating. Human in the loop, as always. Right, I have this quite detailed one I'm not going to go through, but a lot of people also ask, like, what do I do after the first frag? So I think there are 2 paths. So on the left-hand side is what I consider more hardcore. You want to go down into the AI engineering path. So what that will involve is fine-tuning your LLM. So this is when you take, say, Bedrock Llama, or take a base LLM, you fine-tune it on your own data, you serve it on your own data. You can also follow that by agentic AI. I think the previous presenter just mentioned. Then you can run multi-modality, so that's when the LLM work on both text and video and audio. And then you can keep going down, such as expanding LLM vocabulary. So say for medicine or legal use cases, there are some specific noun that's not available in the normal LLM. So you can train that by adding vocabulary. And then finally, you can add context window and add reinforcement learning and distillation. This is hardcore AI engineering route, yeah? And then on the left-hand side is path 2, is what I think most people or most companies will do. They will use LLM as a feature extractor that goes into some sort of marketing or machine learning model. So for example, you have call transcript with customer or emails. You put an LLM to say, is the customer complaining? Is the customer happy with the service? All of that becomes metadata or goes to your feature store for future machine learning. And then you can keep going down there as LLM for product embedding, for example, if you're running a recommender system. So this one is a little bit less hardcore, more traditional machine learning, but both paths are popular. Yeah. Right, that's it.